Will you get accepted to college? Hopefully, the answer is yes. Again, we were talking about Michigan and Ohio State, boo. And then we totaled all of them up. We said that there's two samples. We said that there's one variable. We stated the null, we stated the alternative, and then we said, what is the acceptance rate for all of the students in the sample? We said that was 0.3. So that took us up yesterday until question number 5. Okay, now question number 6, find the expected count, assuming the null hypothesis is true. So how many people would we have that are from Michigan that would be accepted? Say again. Not 31. What's going to be expected? So what is the acceptance rate? David not here. Oh. No, it's okay. So out of the total 105, okay, how many should be coming from Michigan? Okay, so to find this expected, we're going to have to do expected count is your row total times your column total divided by the grand total. Okay. No, I'm not making things up. So the row total times the column total divided by the grand total. Yes, because that gives us 60. Oh. So looking up at the top chart, what was the total this way? It was 105. What's the total this way? 200. Multiply those together, and then you're dividing by 350. That is 60. Okay. Now, if the total is 105, what does that make this one then? There you go. Okay, so for denied, we're going to do 180 times 200. And then divide by 350. 102.9 roughly. I'm going to give you the next one, 37.1. And then to find the Ohio State one, we're going to take 180, subtract 102.9, and that's going to give us 77.1. If we take 65 and subtract 37.1, that's going to give us 27.9. Very good. Not the ye. Yes, very good. They're on the YouTube, same doc. Yep. So what are the degrees of freedom on this one? Well, how many rows do we have? 3. Okay, so 3 minus 1. And how many columns do we have? 2. 2 minus 1. So what's 3 minus 1? And 2 minus 1? So how many degrees of freedom do we have? Remember, degrees of freedom is talking about the number of categories minus 1. What, Mo? Why is it minus 1? I think we talked about this yesterday. We're looking at all potential possible categories. Yeah. One of them what? One of them is likely to be wrong or like an outlier or that kind of thing. So we kind of narrow our search just a little bit. Why is only one? Kind of how the formula goes. Yeah. I wish I could give you a better answer. I don't have one. Yep. Okay, that's from yesterday. I was there that way. Okay. Good? Flip the page. Lift the page. Okay, so is there convincing evidence, statistical evidence of a difference in the distribution of admission decision for the University of Michigan and Ohio State? Okay, so they already did the choose part for you. Yay. So chi-squared test for homogeneity. Somebody say it. Homogeneity. No, I can't say it. There it is. Okay. Anemone. So chi-squared test. Okay. This is different we're starting to get more types of tests. So we have Z tests, we have chi-squared tests. Chi-squared is the little x. Yeah. All right. So the significance level is going to be 0.05. The hypothesis, the null is going to be that there's no difference in the distribution because that's what we're trying to find, right? And then there you are. Alternative is that there is a difference in the distribution. Okay, we're going to check our samples. So, we're doing the most and the least all at the same time. Is there infinite random samples? Did it state in our thing? Okay, yes, it did. So we can generalize to populations, right? All right, and then on the 10% rule, we have 200 is less than 10% of all applicants from Michigan. Hey, I really wanted to see you. Whatever you gotta say. Okay. What? What does that mean?
It's like a person.
You look that up.
No, I just don't want something.
Stay over there. Stay over there. Leave him alone, Mo. You don't start being nice. I'm gonna call your mom. It's gonna happen. All right. So 200 is less than 10% of all applicants from the University of Michigan. And then 150 is less than or equal to 10% of all the applicants at that bad school. Okay. Yeah. Any of you go to Ohio State, I'm disowning you as my student.
Oh, wow.
No pressure. Okay. Large counts, all expected counts. We're trying to check and make sure that they're greater than or greater than 5. Remember, this is the chain. Yeah. This is the new part of large counts. It's got to be greater than 5. It's not greater than 10. But we can do this so that our sample distribution is chi-squared instead of approximately normal. We do have to say approximately chi-squared. And it's not chi-squared. Yes, still the same thing. Problem is, it's got to be greater than 5. When we do the expected count, we get 60, 102.9. We did this on the previous page. 37.1, 45, 77.1, and 27.9. They are greater than 5. Specific formula. So remember, the specific formula for this guy is chi-squared is equal to the summation of observed minus expected squared divided by expected. You've seen this before in your science classes. You've seen this before in some algebra classes as well. Okay, so now we're going to actually plug in the numbers. So chi-squared is equal to 31 minus 60 divided by 60. I got to square that guy up top. Plus 114 minus 102.9. Oh, God. 102.9 divided by 102.9 plus 55 minus 37.1 squared divided by, this is getting worse, 37.1. And yes, I'm going to ... But on your FRQ, you can't ... I just work here. Okay. So then we've got 10 minus 27.9 squared divided by 27.9. When you do all of that tomfoolery, remember, you're going to show that you simplified all of the fractions. That means that you're going to get, like, this simplified would give us 14. Oh. That simplified would give us 1.2, then 8.6, then 18.7, 1.6, 11.5. All that jazz will equal 55.6. That is not the p-value, that's the test statistic. test statistic. So the chi-squared is what we just found, which is 55.6. Good. Man. Hey, friend. Hey, Alicia, you get an award. Everybody clap. Gordon, I'm gonna tell you. How was that? Congratulations. I have to show up when I can just get it later. Congratulations. Oh, Caitlin, we're having our own academic letter. Nice. That's fine. Congratulations. Cheyenne, Henry. Thank you. Okay. Congratulations. You're welcome. Luca, and that's a green. Luca? Hey, a free letter today? You see her, send her my way so I can give her this. Okay, so now we're gonna do our p-value. Remember, your calculator does this for you. Okay, so if you go to your how-to calculator page on Fullread, what happens is you will type in the expected, then you'll type in the observed, and then you will hit menu. And I'm going to pull this up for my people who weren't here yesterday. There's a shortcut too. Yeah. There's a shortcut to the shortcut. Wild. Okay. So if you weren't here yesterday, you type in your list separately. Then you hit menu, statistics, stats test, the chi-squared, goodness of fits. Okay. Good. So when you do that, you're going to get a p-value that looks a little crazy. All right, that p-value is going to be 8.84 times 10 raised to the negative 13. So we're going to say that's about 0. Okay. I just work here. So now your picture, remember with chi-squared, we're going to have kind of like a little right skewed thing chilling. Okay. Our chi-squared value is 55.6. How many degrees of freedom did we have? Dose. Yeah. What? We used our calculator. Or you can go into your table on your orange sheet, and on the last page, there's a chi-squared table. I'm going to be perfectly honest with you, though. It's easier to just plug it into your calculator. Big fan of the calculator. It's the t-table, honestly, I don't think I've used it ever. So, yeah. Exactly. Use your calculator, Mo. What? Okay. So menu, statistics, distributions, and then you go from there. Are you ready? Okay. On the last part, the conclusion. Okay, for the conclusion, we're going to assume the null is true. Bro. So we assume that the null is true. That means that there is no difference. Oh, this keeps getting worse. Between Michigan and that other school that sucks. So there is a about 0 probability of getting a chi-squared of 55.6 or, I'm sorry, greater purely by chance. The ancient text. Good. All right, so assume the null is true. There's no, God bless, no difference.
Oh, that's a no? I thought it was less than 0.
There is about a 0 probability of getting a chi-squared 55.6 or greater purely by chance. I will say this. Let me go off record. Hold on. Ready? Okay. So now, since we had, so because 0 is less than 0.05, we reject the null. And do we have convincing evidence or do we not have convincing evidence? We do that there's a difference. We do have convincing evidence. There is a difference. Okay. Now, here's the new part for chi-squared. The largest component of chi-squared is 18.7. So earlier we wrote out all of those little fractions summarized or simplified. That's 18.7 because that bad school who what? Because the count of the bad school, I'm like, I swear. Come on. It's the tablet. I think it's done. I think we're done. I mean, I guess.
Wait.
What's your question, David? Okay. We are concluding. So we assume that the null is true. There's no difference. There is a 0 probability of getting a chi-squared of 55.6 or greater purely by chance. Then, because we have a probability of 0, which is less than 0.05, which is our alpha, we reject the null. We do have convincing evidence that there's a difference. Okay? The largest component of chi-squared is 18.7 because the count of the Ohio State applicants was greater than expected. So on the previous one, when we did calculate, if you did all of the observed minus expected squared divided by expected, and you simplified all those fractions, you would have had 14, 1.2, 8.6, and 18.7, 1.6, and 11.5. Biggest one is 18.7. Yeah, you missed the calculation part. I think that's why it's confusing.
I want to know why we.
It's the follow-up analysis. It's kind of giving more evidence for the fact that we can reject the null and we can say that we have convincing evidence. What's the biggest impact with all of that?
You said what's the biggest difference?
Yeah.
So what makes the numbers so great that it's so far away from being like zero? Because no matter how the like the closer it is to zero, the more aligned the two numbers are to one another. So the greatest value shows that there's a value that's like very far away from the expected value, which is yeah. So the 18.1 is going to be like 50% are certain expected of I don't know which one specifically, even if that was. But like whichever one that would correspond to, that variable is very powerful.
2, 3, 4, 2, 3, 4.
That's like 74 difference is one of our grades of
That was Ohio State being accepted.
so Ohio State is really accepted as the percentage.
That means that Ohio State just lets anybody in.
Yeah.
So that because it impacts, it's the difference between if I'm going to apply to Michigan or if I'm going to apply to Ohio State, who's more likely to accept me then? Ohio State is.
That's what you're trying to explain.
Yeah. It means Ohio State doesn't have standards. So explain how this test is different from the chi-squared test of goodness of fit. All right, this is the important part. Ready? So the difference between goodness of fit is that we have two samples. Oh, now it went to work. From two populations. The chi-squared goodness of fit, I spoke too soon, has one sample from one population. Okay, the difference between the homogeneity, okay, and the goodness of fit is one sample, one population, two samples, two populations. Make sense? What kind of test should be used for this situation? Would you reject the null? Would you fail to reject the null? All of that. What conditions are met? Okay, go ahead and flip the page. Let's summarize. We gotta do this quick. Okay. So the first thing that we learned about was expected counts. So when we have like a two-way table, what we did with expected counts is we said the row total times the column total divided by the grand total. We're still using the 4 C's. Remember, on y'all's last like test and quiz, y'all took the choose part. One column. Okay. So the 4 C's, you're gonna choose. Remember, it's a chi-squared test for homogeneity. That one. Okay. The null is gonna be no difference. The alternative is that there is a difference. You're gonna check the random 10% and large counts. We're gonna calculate using the chi-squared. So summation of observed minus expected squared divided by expected. And then you're going to conclude, which is going to interpret the p-value, make your decision, and whether or not there should be a follow-up analysis. Okay, I'm going to give you 5 minutes to do this one, and we're going to move on. So, yeah, super fast. All right, so first thing you should have done is totaled up your columns and rows. 25 all the way across the bottom, 44, 56, 100. Good? All right, next part. Is there convincing statistical evidence that there is a difference? There is a difference in the distribution of college planning across the 4 grade levels. If you ever get this question, this is where you start doing the choose. Like, I mean, all 4. Yeah. Okay. So the null hypothesis. Let's go ahead. Talk about that. That's going to be that there is no difference in the distribution of college planning across, oh, can't spell. No. Across 4 grade levels. All right. Alternative is going to be the exact same thing. And you're going to say that there is a difference. Why do we put no difference here and a difference here? Boo. So, right, HO is always what our claim is. Pay attention to it. Yes? Okay. Show the calculation for the expected counts of seniors who started college planning. Say again? It is. There is a difference. Oh. I'm sorry. There is no difference. So the null is going to be that there's no difference. The alternative is that there is a difference. Thank you, David. Okay. That's always. The null is no difference. The alternative is difference. Set it backwards. Okay. Show the calculation for expected counts of seniors who have started college planning. So the way we did this is we multiplied the rows in the column and then divided by the total. So like for this first one, you're going to do 44 times 25 and then divide it by 100. And so that's going to give me 11. You should have gotten 11 here, 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 14 here. Okay. Again, I did row times column divided by 100 and got 11 for all of these. All of them have to add up to equal 25. So 25 minus 11 gave me 14. Good. Great. Calculate the value of the chi-squared. So when you do this by hand, remember, you've got to show the math. So we're going to do 3 minus 11 squared. I don't know why that parentheses is like that. Get rid of him. Divided by 11 plus 12 minus 11 divided by 11 all the way to 10 minus 14 divided by 14. You have to show what these simplify to. So that's going to be 5.8 plus 0.1 plus 0.8 plus 1.5 plus 4.6 plus 0.1 plus 0.6 plus 1.1 equals 14.6. What's our biggest influencer? Freshman who said yes. Because every freshman says that they want to go to college, right? Until they get to be a senior and they're like, well, maybe not. Good? All right, go ahead and flip the page. Flip, 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 flip. Last one, yo. Yeah, they keep bringing all these back, right? That's done. We're back to it. Okay, so are taco tongue and evil eyebrow independent? We asked this question in like unit 3, right? Okay, so is there an association between taco tongue and evil eyebrow? Here's a two-way table from random sample of 600 senior students. Could you imagine coming in and them being like, hey, do this. Like, it's weird. All right. Is there convincing evidence for that the ability to do Taco Tongue and Evil Eyebrow are associated for all seniors? So here is your data. Okay. Now we're going to do the expected. Remember, the expected is your row total times your column total divided by your grand total. So we would do 200 times 480 divided by 600, and that would give me 160. That's a 0. It's a 0. I'm drawing in a circle. Okay. Then you're going to do, that's going to give me 320 here, because remember, it's got to add up to equal that total. Okay. On this one, it's going to give me 40, because it's got to add up to equal 200, and then 80 to get that last one. Good. How many samples? How many variables? How many samples? One sample. How many variables? 2 variables. Lord. It is very cryptic. Like, what is going on? What did you say? I'm not. Sample 2 variables. Not this. I mean, like, it's lagging so bad. Okay, good. So here's why this is a new test. This is going to be the chi-squared test for association, also known as the chi-squared test for independence. So for your choose procedure, you're going to put chi-squared test for association and chi-squared test for independence. I'm pretty sure this is the internet. It's like lag. It's not my fault. Maybe. Chi-squared. Nope. Bigger. Text box. Here we go. Chi-squared test for association. Chi-squared test for independence. Better? Okay. Then we got our null hypothesis. Our null is going to be that Taco Tongue and Evil Eyebrow you missed it when you walked in late, are not associated for all seniors. The alternative is Taco Tongue and Evil Eyebrow are associated for all seniors. Boom. Look at that. Look at it. Oh, no. All right. Your significance level is still 0.05. It's always going to be 0.05 until somebody tells you otherwise. So which one of these statements, null or alternative? Oh my God, what's up?
What do we put for procedure?
Chi-squared test for association. Chi-squared test for independence. Mo. Okay. So which one is independent? Which one's not independent? If they're not associated, that would mean that they're independent, right? Okay, they don't need no man. If they are associated, then they are not independent. We see, we write it down. Null is independent. Alternative, not independent. Null, independent. Alternative, not independent. All right, text box part 2. Yep. Right next to it. Right. For random, we had a random sample of 600 seniors. For the 10% rule, we had 600 is less than or equal to 10% of all seniors. And large counts, all expected values or expected counts are greater than 5. So the sampling distribution is approximately what? Don't say normal. Chi squared. If you say chi one more time.
I still can't remember.
Chi latte. Okay. Your specific formula, that's chi squared is equal to the summation of your observed minus your expected squared divided by expected. All of these have the same setup. The only difference is remembering whether you have 2 samples, 1 variable, 2 samples, 2 variables, 1 sample, 1 variable. That is the only difference between all of these. Yes, no, maybe. Okay. Now go back. You're welcome. All right. So the specific formula, you're going to have the summation of observed minus the expected squared, divided by expected. We're going to plug in all the numbers. So chi squared is equal to 180 minus 160 divided by 160. Don't forget your squared. And then 300 minus 320 divided by 320, the squared. And 20 minus 40 squared divided by 40 plus 100 minus 80 divided by 80. So all we did was we took our expected and our observed, we subtracted them, we divided it. Then we have to simplify each one of these fractions. So that's going to give me 2.5 plus 1.25 plus 10 plus 5. That's going to equal 18.75. What's your biggest influencer? 10. 10 plus 5, right? Okay, so we're going to have 10. And which one is that? Like, okay, but like in context. Yeah, no taco tongue, yes, evil eyebrow. Why? Those are like weird people. You can evil eyebrow, but you can't taco tongue? Like the greatest impact. The greatest impact, remember how we talked about like the largest component of chi-squared?
Right. I was a whole different test. So what's it significant?
Remember, the only difference between the tests is what? Variables.
Yes.
We're going to summarize the 3 tests in just a second. Okay. Now, your picture, remember, this is always going to be right skewed. Thank you. All right. How many degrees of freedom do we have? How many categories do we have? Minus is, we got 1 degree of freedom. That's it. That's all you got. S statistic is chi-squared, which is 18.75. How do we find our p-value?
Okay, well, it's statistics.
Yeah.
Distribution.
Okay.
8.
Okay. Watching brain overload right now.
What's the first one?
You do your observed list, your expected list, and then you put in your degrees of freedom. Okay, so when you do that, your p-value should be 0.0000015. Okay, so now we're going to do our conclusion. Again, same thing as what we did on the last one. Okay, so assuming that the null is true, that means that there's no association. Remember, when you state the null, you got to remind your reader because they might have forgotten since the last time you've already told them. Okay. I always felt like on the AP exam, they always... Again? Why do we only have 2 categories?
Can you just add it or can you find those?
But it's also asking for whether you like yes, no, or unsure. One is also about
So assuming the null is true, which means that there's no association, there is a 0.00015 probability of getting a chi-squared of 18.75 or greater purely by chance. And because 0.00015 is less than 0.05, we reject the null and do have convincing evidence. There is an association between Taco Tongue and Evil Eyebrow for all seniors. The largest component, come on, of chi-squared is 10 because the count of yes, Taco Tongue, no, Evil Eyebrow was lower than expected.
Someone's really gonna sit there and read all of that.
Yes, that's their job. What does chi-squared mean? It's the summation of your observed minus your expected. So it's the difference between what we expect versus what actually happened in the experiment. Does that help?
So like, no, so like when you get a B score or whatever, right? Like,
Right.
you know that that's the amount of deviation of the
Mhm.
what is like, what is that?
How big of a differences are expected from our observed? So it's kind of like z-score, kind of, but that's in relative to the mean.
So the higher it is, the more
The more of a difference between your observed and expected. Yes.
There was a question on the report and on this, like, what have like the biggest, like, large count? Like, and they gave us like several graphs, like those on the back.
Yeah.
How would you like figure that out?
It's like how spread out it is. I'll have to look at the graphs again in just a second. All right, go ahead and flip the page. We got to talk about the 3 different types of tests. Okay. Go and flip the page. We got the 3 tests. Yeah, that's fine. Okay, the 3 different tests for chi-square goodness of fit. Okay. Okay. So the 3 different types that we got. We're just gonna use the text box. Okay. All right, we had chi-squared goodness of fit. That's where we had 1 sample, 1 variable. The example of that was the M&Ms. Okay. We have chi-squared test for homogeneity. Yeah. That was the college admissions one. And that was 2 plus samples and 1 variable. And that was the college admissions one. And then we talked about chi-squared test for independence. And that's 1 sample, 2 variables. And that's talking about Taco Tongue and Evil Eyebrow. We still did the whole 4 C's method. Okay, that doesn't go away with either one of these. Okay, so on these next three questions, what you're doing is you're deciding which chi-squared test would work for which one and why. It's independence association.
So why do you write both? Or do you tell them to put it on?
So you know that there is
Good? Okay, I want you to go ahead, read over those three scenarios. Tell me which chi-squared test we got. Okay, you got like 5 minutes. Let's go. Go, 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 go. Okay. A random sample of 200 students was asked to sample a new type of pizza the school was going to consider for using a replacement for the current pizza. Each student stated if they were a freshman, sophomore, junior, or senior, and if they liked the pizza more than the current pizza. The school would like to know if there's an association between grade level and pizza option. First of all, how many samples? There's one sample we pulled from 200 kiddos. Yes? How many variables? 2 variables. That's grade level and pizza opinion. So, what is the chi-square test? For independence. Okay. Since they were asking about if there was an association, that was your tell. Yes? Okay. That's why we wrote down association. Okay, good job. All right, on the next one. Another school is also considering changing their pizza vendor. Why? This school selects separate random samples of 50 freshmen, 50 sophomores, 50 juniors, 50 seniors. Each student tries a new pizza, states whether or not they like it more than the current pizza or not. The school would like to know if the distribution of the opinion differs across the grade levels. How many samples do we have? What are they? Freshman, sophomore, junior, senior. How many variables? Either they like it or they don't, right? One variable. What kind is that guy? Oh, wow. Okay. Plus. Okay, so this is chi-squared test for homo. D. That was close. All right, on the last one, a large pizza chain claims that 30% of their orders are placed on Fridays, 20% are placed on Saturdays, 10% are placed. Okay, blah. And how many samples do we have? How many variables? Okay, goodness of fit. Yes? Everybody got it? Questions? Fantastic. Here's what I want us to do. Okay, you should have worked on your 12.1 homework last night. If you didn't, that is due tomorrow. Go, Victoria.
I have like a question on the homework.
Okay, so with that being said, I'm gonna give you a couple minutes. We're gonna do a 5-question multiple choice quiz really quick.
No,
It's not bad. It is not bad. Not bad. Okay. All right, Victoria, come here. All right, 5 minutes. You got